Okay, we're now going to look at our final thing dealing with inequalities, and this is rational inequalities. Just like with polynomial inequalities, we're going to solve these just like we would solve rational equations, except we have to again be concerned about our inequalities and then also what intervals are going to be in our solution. So let's first look at a relatively straightforward example of 2 over x plus 5 being greater than 1 over x minus 3. Now the first thing we want to look at here is seeing that we have some things that don't work in our denominators. So I always like to put those down first. X, for instance, can't be negative 5, and x can't be positive 3. And the reason I'm putting those down right away is that when we start our number lines, we're going to have to put open circles there right away because those can't be part of it. So actually, I might put x's there instead, because then we'll have to check intervals as well. All right, now let's go ahead and look at this. Well, I would do this, I mean, you could do cross multiplying, but I like to think of it still like we did the other ones, where I have 2 over x plus 5, and then I'm going to multiply to get rid of denominators. So I'd multiply by an x plus 5 to get rid of this denominator, but then I'd also have to multiply by an x minus 3 to get rid of this denominator. So you have to multiply both sides by that. And this is greater than 1 over x minus 3 times x plus 5, x minus 3. And then, of course, we get to cancel out just like we normally would. Cancel out the x minus 3's, cancel out the x plus 5's, and then write down our simplified equation at this point. So we'd again wind up with 2x times the quantity x minus 3 is greater than 1 times x plus 5. Now we just solve this like any inequality, and we'd have 2x minus 6 is greater than x plus 5. Subtract x from both sides, and we'd get x minus 6 is greater than 5. Add 6 to both sides, and we get x is greater than 11. And so now I'm going to go ahead, actually, I'm going to still graph this because we want to make sure that this is the complete solution here. And what do I mean by that? Well, what are the numbers I can't be? I can't be negative 5, so I'm going to put negative 5 here. And I'm going to say I can't be negative 5, so I'm going to put an x through it. I also can't be positive 3, which I'll put like right here. I'm going to put an x through that. And then where do I start here? Well, I start at 11. And so this is an open circle. And then I'm greater than 11. So I go all the way to the right. And so I don't have to worry about the fact that I have 3 and negative 5 here. I'm okay. And so my answer is x greater than 11. And if you write this in interval notation, this would be 11 parenthesis to infinity parenthesis. Now, you might say, okay, well, why did I even bother with those those minus 3 and 3's? Well, let's make one small change in this problem, and we'll see how that comes into play here. 2 over x plus 5, instead of it being greater than, we'll say it's less than 1 over x minus 3. And so we still have that x can't be negative 5 and x can't be positive 3. Okay, well, we'd still solve the equation the exact same way. I'm not going to solve the equation again. I'll say dot dot dot, and we'd wind up with x being less than 11. Alright, so if x is less than 11, what do we have here? Well, I'm going to again do a number line. And I'm going to go ahead and put here that negative 5, I can't be there. And positive 3, can't be there. And then I have 11. But then I'm all the way to the left, but then I hit this, I can't be it. So I'm going to then draw kind of a circle there, because it can't be 3. And I keep going to the left. Oh wait, it can't be negative 5, so I draw a circle there. And so this is the graph of the solution. Now writing this as inequalities would be kind of challenging. The answer is not x less than 11. If you were to write x less than 11, you would actually be wrong because you have to exclude these points 3 and negative 5. But we could fairly easily write this in interval notation as negative infinity to negative 5 unioned with negative 5 to negative 3, not negative 3, positive 3. Come on, there we go. Unioned with 3 to 11. So you do have to be careful with rational functions on whether or not the denominators are allowed as far as part of your answer. All right, so let's look at another example here. So we've got 1 over x minus 3 is less than or equal to 9 over 4x plus 3. And then again, I'm going to write down the values that x can't be. X can't be 3, and x can't be negative 3/4. Okay, now we're going to solve this same way as we did the other problem. So I'd have 1 over x minus 3. I'm going to clear these fractions out. So I'm going to multiply by x minus 3, and then 4x plus 3. And then this is less than or equal to 9 over 4x plus 3, and then this would be times x minus 3 times 4x plus 3. And then we can cancel. X minus 3's would cancel here, and these 4x plus 3's would cancel on the right hand side. So then the left hand side just becomes 4x plus 3 is less than or equal to 9 times x minus 3. So we'll distribute that out. 4x plus 3 less than or equal to 9x minus 27. And so I'll go ahead and subtract the 4x. So we have 3 is less than or equal to 5x minus 27. Add 27 both sides, you get 30 less than or equal to 5x. Divide both sides by 5, and you get 6 is less than or equal to x. So let's make sure by graphing our number line and the points that we can't be that this is fine as a solution. Okay, so let's see here. What are the numbers we're not allowed to be? We're not allowed to be negative 3/4. So negative 3/4. Can't be that. We can't be positive 3. And now it's x is greater than or equal to 6, or you can think of 6 is less than or equal to x. So if this is 6, I'm going to get a solid dot here. And since x is greater than or equal to it, I shade to the right. And I can see that I'm not hitting any of those points that are bad. And so my answer of x being greater than or equal to 6 is just fine. And then again, if I wanted to write this as an interval, this would be 6 to infinity. Oh, except I made one mistake. It's not a parenthesis, it's a square bracket because we include 6. I'd like to look at one more example here, and then that will wrap up our videos on inequalities. So this last one here is 3 over x minus 1 plus 2x over x plus 1 is greater than negative 1. And again, we're going to put down what x can't be. X can't be 1 or negative 1. Now we're going to solve this just like we've been doing all of the other problems. And so we'd have 3 over x minus 1 times x minus 1 times x plus 1 plus 2x over x plus 1 times x minus 1 times x plus 1 is greater than 1, negative 1, times x minus 1, x plus 1. Then simplifying, of course, these x minus 1s would cancel, the x plus 1s would cancel, and then the left-hand side here, we'd have 3 times x plus 1 plus 2x times x minus 1 is greater than negative 1 times x minus 1 x plus 1. Alright, now we got to solve this, so we'll distribute everything. So we have 3x plus 3 plus 2x squared minus 2 is greater than negative x squared minus 1. So we'll go ahead and combine some terms here. 2x squared plus 3x. 3 minus 2 would be plus 1. And this is greater than, distributing the negative, negative x squared plus 1. Adding x squared to both sides, we'd get 3x squared plus 3x. Subtracting 1 from both sides, you get 0. So we have 3x squared plus 3x is greater than 0. Okay, well then, what do we need to do here? Well, we're going to go ahead and factor. So we'd factor out a 3x, and you'd be left with x plus 1. And so x is 0, or I'm sorry, not 0. I'm thinking I'm solving an equation here. We have 3x times x plus 1 is greater than 0. Now we're ready to go to the number line and having to do our interval tests and also what x can or can't be. So let's get my number line drawn here. Okay, so first off, let's go ahead and put what x can't be. Negative 1 and 1. It can't be those. Okay, so then let's go ahead and see what the solutions here would be. 3 times x, x would give me a solution of 0. So I'll go ahead and put in 0 here. I'll just put it right here. And so we'd have an open circle at 0. And then this is negative 1, which also would mean, even though I don't get to include negative 1, that's fine, because an open circle means I don't include it. And so I would have that. Now I have 3 intervals I have to test here. 1, 2, 3. Now, I don't have a 4th interval. This x not being 1 just means I can't use 1 as my test. I'd have to use something else. So I'm going to have to test 3 intervals here. So let's test interval 1. And let's use x equals negative 2. So you'd have 3 times negative 2 times negative 2 plus 1 being greater than 0. So this would be negative 6 times negative 1 being greater than 0, which gets you 6 greater than 0, which that is true. So that means we get to include this first interval. So I'll kind of shade that in there. Well, now we got to just test other ones. So let's look at interval 2. Well, I need to pick something in there. So I would pick maybe negative 1/2. And so then you'd have 3 times negative 1/2, negative 1/2 plus 1, greater than 0. And this would be negative 3/2 times 1/2, greater than 0, which would be negative 3/4, greater than 0, which that clearly is not true. So interval 2 is not there. Now we need to test interval 3. Now I can't use 1 because 1's not allowed as a value. But I could go ahead and test, for instance, x equals 2. So x equals 2. And if we test that one there, we'd have 3 times 2 times 2 plus 1 being greater than 0. So you'd have 6 times 3 being greater than 0. 18 is greater than 0. And of course that's true. So we get to include everything greater than 0. But then as I start shading in, oh, I hit what I can't be, which is 1. And then I continue shading up here. And again, writing this as an inequality would be a little challenging, but we could definitely write this in interval notation. So we would go from negative infinity to -1, union with the interval 0 to 1, unioned with the interval 1 to infinity. Alright, so that wraps us up on inequalities. And we will begin next week, or I shouldn't say next week, next set of videos talking about linear equations and functions as well.